Hi everyone, this is Sugantha Priya, Assistant Professor, Department of Computer Science, Full Stack Web Development, Dr.S.N.S. Rajalakshmi College of Arts and Science. This presentation is about the topic, the changing nature of the software. So this slide explains the how modern software development is shaped by multiple interconnected factors. The chain diagram shows that the changes in the software do not happen in isolation. Instead, each factor influences and strengthens the next. First is the hardware advancements. Improvements in processors, memory, storage and devices have made systems faster, smaller and more powerful. This allows software to handle complex tasks such as real-time processing, AI and high-quality graphics. Next is the internet growth. The rapid expansion of the internet has transformed software from standalone applications to connected systems. Next is the mobile device proliferation. The widespread use of smartphones and tablets has shifted software design towards mobile first and responsive applications. Next is the data driven applications. Many modern software increasingly relies on data for decision making. Analytics, big data, and machine learning enable applications to personalize services, predict trends, and improve the efficiency. Next is the challenges. With the growth comes challenges such as security threats, scalability issues, privacy concerns, and need for frequent updates. Developers must manage the complexity while ensuring reliability and performance. Next is the opportunities. Despite challenges, the evolving landscape creates opportunities for innovation such as AI-based systems, cloud services, automation, and smart applications that improve the business and the user experience. Next is the software evolution. So this slide represents the historical evolution of software by highlighting major milestones across different decades. It shows how the software has transformed from hardware dependent programs to flexible platform independent systems. In the early 1915s, the early computing era, in the initial stage of computing, software has tightly coupled with the hardware. Programs were written specifically for individual machines using low level languages like machine code and assembly language. Next is in the early 1960s, that is the operating systems and the databases, that is a system oriented design. So this era marked the introduction of OS and database systems which abstracted hardware and details from the user. Next is in the 1990s was the internet revolution. So the globally connected software, with the rise of the internet, software become the network oriented and globally accessible. Next is 2000s mobile and cloud era, that is platform independent softwares were introduced. So modern software evolved to support multiple platforms and devices. So the growth of smartphones and mobile applications, cloud computing enabled, scalable and on demand services, and also the software designed to run across different operating systems and environment. So this slide shows that the software evolution is driven by technological advancement and the user need. So each stage reflects increasing abstraction, connectivity, and flexibility, shaping today's modern intelligence and scalable software systems. So next is the evolution of software engineering. This slide shows how software engineering has evolved from manual or rigid practices to modern, automated, and intelligent approaches. The arrow represents a clear transition from traditional development methods to advanced technologies. So first is a manual development, that is a traditional approach. In early stages, software development was mostly manual. The code was written, tested and deployed by hand. Limited tools and automation was done and development cycles were slow and error prone. Next is agile methodologies. Agile introduced flexibility and collaboration into software engineering practices. So that is in this methodology we introduced iterative and incremental development, continuous customer feedback, faster delivery and improved quality. Next is a microservice architecture. So the software systems moved from monolithic designs to microservices. Applications are broken into smaller and independent services. It is easier to maintain and scalability. Next, for faster updates without affecting the entire system, we can go for this microservices architecture. So next is a low code, no code platform. These platforms simplified the software development due to rapid application development with minimal coding, enables non-programmers to build applications and also it reduces development time and the cost. So next is the security. Security became an integral part of the development life cycle. Proactive identification of vulnerabilities was done, secure coding practices was done and continuous security testing was done. Next is the DevOps. DevOps bridges development and operation teams. So continuous integration and continuous deployment, automated testing and deployment, faster and more reliable software releases were done. Next is the cloud computing. Cloud platforms transformed infrastructure management like on-demand computing resources. So next is AI and ML. The last stage introduces the intelligent system software systems. So software can learn from data. We can introduce predictive analysis and automation. Next is the uh, pros of the software engineering. So the pros of the software engineering include innovative solutions, so cutting edge technology, positive impact, high demand, etc. And also we can go for technological updates, complexity, security risk, and skill gap. So the software engineering offers innovation, impact, and strong career prospects, and also it demands adaptability, continuous learning, and careful management of complexity and security risk. This slide represents a mind map that summarizes the entire topic, the changing nature of the software and engineering. It visually connects all key components discussed in the previous slides, and also it helps how the ideas are related. Thank you.